There are going to be a couple of fatty acids that are unsaturated that are super important to our health and well-being. They are really important for a number of regulatory functions as well as other physiological functions that include things like regulating your blood pressure and making sure your blood can clot. They are going to be omega-3 linolenic acid and omega-6 linolenic acid. They're generally known as the omega oils or omega-3 and omega-6. This shows you a couple of common lipid structures. The one that is on top, if you see this, you can see phosphorus containing group. So this is going to be a phospholipid, because here's the phospho and here's the lipid portion. You see that little kink? That little kink is going to tell you there's a double bond there. And sure enough, there is. Could be a triple bond. Stay tuned on that. We're talking more about saturations. And then down below, you will see a couple of steroid formations. Now, saturation. What's the diff between unsaturated fats and saturated fats? Unsaturated fats are animal fats. They're going to be solid at room temperature. Unsaturated fats are going to be, for the most part, liquid at room temperature. They're going to be the plant fats. The difference in saturation depends on the chemical bond structure. Saturated fats will be entirely formed from single bonds in between carbons. That means they're going to have a more stable structure, and the fat will also contain more hydrogen molecules. Unsaturated fats or unsaturated fatty acids will be missing some hydrogen atoms and has at least one, generally more, double bond between carbons. And it'll give you that kinked look to the fatty acid that I mentioned before. So unsaturated fats will have double or triple bonds and oftentimes more than one. The double bond makes, or triple bond, makes that fatty acid more flexible and therefore more likely to be liquid at room temperature. If you have a monounsaturated fat or fatty acid, you only have one double bond between carbon atoms. They're still liquid at room temp. If they are refrigerated, they will get cloudy as they cool. Think olive oil, think canola oil. That's because the fat is becoming slightly solid as it cools. But if you pull that out of the fridge, it'll become clear again. That cloudiness will vanish. Polyunsaturated fats have two or more double or triple bonds between carbon atoms. They are liquid at room temperature. They do not become cloudy if you put them in the fridge. Those multiple double or triple bonds keep that fatty acid, that fat molecule, really flexible at most temperatures. So if you take a look at this diagram, you can see in the structure that's at the top, it looks kind of flat, like a brick. And if you look at the one in the middle, it's got a kink to it. The more double or triple bonds, the more kinks. If you take something that looks like a brick, you can stack that up on top of other structures that are flat like that pretty easily, which is why you end up with a solid fat, because you have a saturated fatty acid and they can lie on top of each other just like you're stacking books. The unsaturated fatty acids can't lie on top of one another. So that's why you have a liquid. While we're looking at this diagram, I want you to look at where the hydrogens are that are attached to the carbons that are they themselves attached by that double bond. See how the hydrogens are both on the same side? In the bottom picture, you will see that it's kind of flat, kind of like a brick or a book. And you will see that the hydrogens are opposing on opposing sides. They're not on the same side as they are in the unsaturated fatty acid. That becomes an incredibly important structure when you are talking about trans fats, and see how that is named trans oleic acid, whereas the one that's in the middle is cis oleic acid. Cis means same side, trans means across. Stay tuned on that. We're going to be talking more about that momentarily. Make sure you watch this video. You know what I'm going to say about assessments. Now, the location of the double or triple bonds can vary. And the way that you name and identify fatty acids, these unsaturated fatty acids, is going to be by the position of the double or the triple bond that's nearest the methyl group at the end of the carbon chain. And methyl is a CH3. So again, fatty acids are going to be named on the location of those double or triple bond positions. The degree of saturation is going to definitely affect how firm, solid or not, that fat is at room temperature, which we just talked about. Polyunsaturated vegetable oils are going to be liquid at room temperature because those chains can't stack on one another. Saturated animal fats, butter, lard are solid. The greater the number of double or triple bonds between carbons, the softer and therefore more liquid that fat will be. Great little animation on lipid structure. And this gives you a list of commonly consumed lipids. You'll notice that coconut oil is considered a saturated plant fat because it is solid at room temperature, although if it gets warm enough, it does turn into liquid. Flaxseed oil is a super important oil because it's going to contain both omega-6s and omega-9s, essential fatty acids. Notice how they're essential. That means you need them in the diet. And saturation has a direct effect on how stable the fat is. All fats, I don't care what type of fat you have, will become rancid if exposed to oxygen over a period of time. The oxidation, try that one again. The oxidation of unsaturated fats will trigger the degradation of that compound, and it's going to smell funny, it's going to taste funny. The more double bonds that you have in a fat, the more easily it will go bad. So I always laugh when I see those giant vats of olive oil, huge containers of olive oil you see in the grocery store. And I think, well, yeah, in the year or two that it takes the average American to go through one of those, you're basically eating rancid fat. And that's because those double and triple bonds are pretty unstable. So if you expose them to heat, you expose them to oxygen, not great for fats, they're going to go rancid. Make sure you watch this, and we'll continue on with more fun information about lipids in the next section.